Hello everyone, welcome to Athena. And in this particular chapter, we are going to dig deeper into Athena, its features, architecture, etc., and where Athena can be used. Just like Redshift, Athena is also divided into multiple sections, but the sections in Athena are not as big as Redshift because overall Athena is a kind of a smaller service than Redshift. So in this particular section, in section 1, I'll introduce you to Athena and its features. And this is going to be the agenda for Athena, or I'll introduce about Athena, then I'll talk about Athena use cases, and then we'll start with Athena objects like database and tables, then the various data types, DDL statements, DML statements. And in Athena, I'll have to talk a little bit about something called SerDe, and you'll find the same SerDe concept in Hive also. And then I'll talk about how you can actually pass parameters while executing query in Athena. Then prepare and execute statement, how you can prepare a statement in Athena and then execute it just like Redshift. How you can handle schema evolution or schema changes in Athena. How to query JSON data using Athena. And then the ACID compliance in Athena using Iceberg, Delta Lake and Hoodie tables. But I'll focus mostly on Iceberg tables. And then I'll conclude section 1 with partitioning and bucketing. So, what is Athena? So, Athena provides an SQL interactive query service which can be used to analyze data that is available in S3. And we can do the analysis using SQL. So, imagine that we are querying or running on data or files that is directly stored in S3. So let's say we have S3, and if we store data in S3, then the metadata of that data or of those files or objects should be stored in Glue data catalog. And then we have Athena service on top of it. And let's say you want to run SQL statement. You send the SQL statement to Athena. It gets the metadata information from Glue data catalog and then runs the query on top of S3. Now the question is how Athena runs these SQL statements. Athena supports two query engines out of the box. One of them is Trino, which is written in Java, and the other one is Spark, which is written in Scala. Both Java and Scala are JVM based programming languages. Just keep that in mind. As of now, these are the only two query engines that are supported by Athena. If we talk about Trino or Spark, both are distributed compute or distributed processing engine or distributed processing framework. So Trino is similar to Presto, or basically Trino used to be Presto and then it is a little more advanced than Presto, but this is also a distributed processing engine. So in this particular chapter on Athena, I'll not talk too much about Spark because I'll have a separate course on Spark itself on Data Engineering Volume 2. So you can go through it if you want to learn more about Spark. We'll mostly talk about Trino here. Now, before going further, of course, it makes sense that we understand the architecture of Trino at a very, very high level. Again, as I said, this is a distributed query processing engine, and it also utilizes the MPP or massively parallel processing provided by something called a Trino cluster, wherein it will have multiple nodes just like Redshift cluster. But in Trino cluster, the nodes are divided in coordinator nodes and worker nodes. By the name, you can imagine that what these things do. Of course, all these nodes are connected to each other, and the client sends SQL query to the coordinator. Now, in our case, the client would be either Athena API or Athena console, etc. It will be sent to the coordinator, and coordinator does certain functionalities or does a few things. For example, it parses the SQL statement that is sent by the client. Then it creates the query plans, and then it also makes sure how the query would be scheduled on the worker nodes, and it also manages the worker nodes. Once the query plan is created, that particular query plan is sent to all the worker nodes for execution. So each worker node would again deal with certain subset of data just like Redshift. Once the entire work is done, the individual result sets from these workers would be sent to the coordinator node, and then coordinator node would aggregate it and then send it back to the client. It is similar to Redshift itself, but the query engine is different than Redshift. It also supports various file formats like CSV, JSON, Parquet, ORC, Avro, etc. And Athena works with Glue Data Catalog and Lake Formation. So you can go through the video of Glue Data Catalog and Lake Formation in the appendix if you don't know about it. If you know about it, you understand that Glue Data Catalog contains the metadata information about all the data stores that we have. If you are using S3 as a data store and we are storing, let's say, CSV, Parquet, Avro, JSON files in S3, the information or the metadata about the structure of those files should be stored in Glue Data Catalog using Glue Crawler, or we can define it by ourselves also. We can define a table or database metadata using Athena SQL also. The moment we query the Athena SQL or we create a table using Athena SQL or create a database using Athena SQL, information about those would be stored in Glue Data Catalog automatically. Athena, of course, has integration with Lake Formation. So Lake Formation provides a centralized governance tool. So you can manage the row level access, column level access, or cell level access. Or you can use Lake Formation tag based access also with Athena. Now, apart from Glue Data Catalog, Athena can also work with Hive Metastore, which is an external data catalog. So if you have to create a Hive Metastore, then we'll need an EMR cluster, or we can use tools or services like RDS and Aurora. And the most important part, Athena is used for ad hoc analytics. So the ad hoc word is pretty important here because it's not that you can use Athena or you should use Athena for regular data analytics. No, that is not the purpose of Athena. We should use Athena for ad hoc analytics only. So that's called for a discussion on Athena use cases. So when to use Athena? So basically, as I already said, it is used for ad hoc analytics queries. It's not that you'll be running or you can use Athena as a data warehouse completely. That is not the case. You should use Athena only for running ad hoc analytics queries. So it is not meant for complex queries with large number of tables and datasets or databases. So you have pretty complex queries, let's say, like you are joining the fact tables and dimension tables in a Snowflake schema, then you should not use Athena. Redshift is a better tool for that. Or if you are using Snowflake as a data warehouse, you should use Snowflake for that, but definitely not Athena. It is used for ad hoc, simpler analytics queries. So one of the very common use cases is Redshift archival. So if you remember, we talked about Redshift archival in the Redshift chapter. So what we do is that we have, let's say, tables in Redshift and those are growing pretty big. What we do is that we use the unload command to extract records from Redshift and store it in S3. This is an archival process. This is not a purging process, meaning that we are not deleting the records. We are not doing away with the records, but we are storing it in some other place so that we reduce the size of the data warehouse in Redshift. So if you are storing and you are not removing the data, it means that the data might be needed in some queries, maybe not that frequently, but maybe once in a month or once in a quarter, so on and so forth. That's why the process is called archiving rather than purging, because we are not removing the data from the system completely. We are just moving the data from one place to another. Because S3 is a cheaper storage, so we are moving the data in S3 data store so that we can gain from the cheaper storage price in S3. But because the records have been archived, it might be used in future to run certain queries. And that's where Athena comes into picture. So if you archive the data from Redshift, you put it in S3 and then use Athena to run those ad hoc queries, maybe once in a month, once in 2 months, or once a quarter, so on and so forth, on the data that has been archived from Redshift to S3. You run only ad hoc queries using Athena. You do not run continuous queries or regular queries or queries that you run on a daily basis on Athena. The another use case is OLTP database archival. So the use case is similar. Let's say we have RDS and Aurora, which are transactional databases, and just like Redshift, we do not want to continuously increase the size of OLTP databases. The threshold for OLTP databases are much lesser than data warehousing systems like Redshift, but let's say there are certain tables wherein we do not want to move the data to Redshift because those are not needed for analytics or in historical data analysis in your Redshift data warehouse. So those records can be moved to S3, and then you can use Athena to run ad hoc queries on top of the files that have been moved from RDS or Aurora to S3. Or if you can move from RDS and Aurora to Redshift and then archive from Redshift and then run Athena on top of it. We use archive or copy to S3 features in RDS and Aurora to copy the files from various tables to S3. Now, not only relational databases, we can use the same use case for non-relational databases also, like DynamoDB. So DynamoDB has a feature called export to S3, and using export to S3, we can archive the data or move the data from DynamoDB to S3. And let's say we have some analytics use cases which cannot be run on DynamoDB. We move them to S3 and then use Athena to run ad hoc queries on top of it. So the question can be, can't we use Redshift Spectrum? Because we have Redshift Spectrum also. The answer is yes, definitely we can use Redshift Spectrum, but the thing is that for Redshift Spectrum to run, we have to make sure that a Redshift cluster is running all the time, or you have a Redshift serverless workgroup running. So if you are not using Redshift at all, let's say instead of Redshift, if you are using Snowflake, but you are storing all your other databases in RDS and DynamoDB and DocumentDB, etc., then you can move the records to S3 and then use Athena on top of it. Otherwise, if you want to use Redshift Spectrum, you'll have to make sure that a Redshift cluster is running or a Redshift serverless workgroup is running. So if you already have a Redshift cluster, provision cluster or serverless workgroup, you can use Redshift Spectrum in that case also. But as I said, Redshift is typically used for very complex queries. So if the queries are not as complex, then Athena can be used. And one more thing is that Athena is completely serverless, meaning that in a true essence, it is serverless. We do not have to provision any resources at all. We have the data on S3. We define the metadata about it in Glue data catalog, and then we go to Athena console or use the Athena API to run queries on top of it. So before proceeding further, let us go ahead and explore the Athena console. So this is the Athena console and this is the landing page of Athena. I already know how to go to a particular service. And these are the options that we have in Athena. We have query editor, notebook explorer, something called workflows, which are basically handled by step functions. These are not run in Athena. And then we have something called work groups and data sources. We'll talk about workgroup in workload management, and data sources is any we'll talk about in the future slides. So if you see, the only thing that actually we have here is the query editor. So either we can launch the query editor from here or we can launch the query editor from here. Either we can query the data using Trino SQL or we can analyze the data using Spark SQL also. So we'll talk only about Trino SQL. Athena for Spark was launched a few months back. So what it does is that if we use Trino, it will go ahead and run a Trino cluster behind the scenes. And if we use, let's say, Athena on Spark, then it will go ahead and run a Spark cluster behind the scene, obviously in a serverless way. No matter what we select, we'll have to launch the query editor and it will give us a console just like query editor v2 in Redshift that we use or run SQL statements here, and that's all we have. Once we run the query statement, of course, there are other features also like query stats, reusing results, etc., which we'll talk about later on. Then we have some other features called recent queries, saved queries, and settings, etc. We'll talk about these things as we go forward. But the purpose to show this console is to tell you that Athena is serverless in a true sense, because we are not provisioning any cluster. We are not even provisioning something like Redshift serverless workgroup. So we just define the metadata and run the queries here. That's it. Or we can use Athena APIs also. And the query will be executed behind the scenes using the resources which are needed for Trino cluster or Spark cluster. So that's about the console. Of course, we'll go deeper into the console once we start the hands-on. This is a familiar diagram. I had already shown you this diagram earlier. Now, where does Athena fit in? So we have on the left hand side, we have data sources. We have ingestion layer. We can use DMS, we can use EMR, Glue, Kinesis, MSK, etc. Either to Redshift, or we can move it to S3 also. Or we can move data from Redshift to S3 also. Or we can move data from OLTP data sources to S3 also. Now Athena fits here in the consume and visualize. Of course, Redshift can also fit here in the consumption layer. But Athena is in a true sense is a consumer, because it reads data from S3 data lake using the Glue data catalog, and will not use Athena for storage for sure, because Athena does not have any storage on its own. Because Athena does not have any storage on its own, the data is stored in S3 and the metadata is stored in Glue data catalog. If we have to look Athena in the context of the entire data pipeline, it sits at the end, just next to Redshift, wherein if we have to run ad hoc queries on S3 or maybe on other data sources also, then we can use Athena for sure. So as I told you in the previous slide, in the data engineering pipeline, that we can use Athena with other sources also. So how we can do that? That is where federated queries come into picture. So it is not like Redshift query federation. So in Redshift query federation, we use, it can be used with RDS MySQL, RDS PostgreSQL, or Aurora MySQL and PostgreSQL. But here we can use Athena federated queries anywhere, which basically gives us the sense of SQL anywhere, meaning that we can run SQL on top of any data store that we have using Athena. The reason we have this SQL on anywhere underlining is because Trino is also same. Trino or Presto is also same. They provide SQL on anywhere feature, and Athena extends that on AWS. Federated queries are used on data sources other than S3. If it is not S3, there can be a lot of other data sources, and the way Athena connects to these data sources are using data source connectors, which translates the language between Athena and other data sources. These data source connectors actually run on AWS Lambda. So let's say we have this data source connector which is on Lambda, and we have Athena on top of it, and then we have other data sources than S3. So whenever we submit an SQL query on Athena, this connector converts that to the corresponding data source, retrieves the record or retrieves the rows, and again converts it back to Athena format and then sends it to the client. And there are a lot of other data sources that can be used. On AWS, we have Redshift, DocumentDB, DynamoDB, RDS, Aurora. So Redshift, we have already talked about. DocumentDB is a MongoDB compatible managed database service, and DynamoDB is a key value store. RDS and Aurora are relational databases. On non-AWS, these are the major data sources. Of course, there are a lot of other data sources also. This is not an exhaustive list. So there's Azure Synapse, Azure Data Lake Storage. On GCP, we have BigQuery. It supports Google Cloud Storage also, which is similar to S3, but that is on Google Cloud. Then it supports HBase also, which is a wide column stored NoSQL database. Then it supports IBM DB2, then Kafka, Redis open source software, Snowflake, Teradata, etc. So these are the other non-S3 data sources that can be queried using Athena, giving you the SQL on anywhere feature. So what are the various data sources or components of data sources that we need? Of course, we have databases and tables which are created in Glue data catalog, either using Glue crawler or using Athena SQL. So we can use both Glue Crawler and Athena SQL to create the databases and tables. So let's say this is the Glue data catalog and we create a database. Tables are nothing but logical grouping which are put inside of a database. And these tables point to a particular location in an S3 bucket or folder or object. So for example, table 1 is pointing to S3//bucket/folder. Table 2 is pointing to an object, and let's say table 3 is pointing to another folder. So Athena is used to query these objects in Glue data catalog. So let's say we have Athena, we send the queries, get the metadata from Glue data catalog, and then execute the queries in Athena. And also the output that is generated by Athena has to be stored somewhere. So the query output is stored in S3. So we have to provide a location in S3 where the query output should be stored.